Bueno, para cerrar la sección de lecciones aprendidas, vamos a recibir una conferencia notable de Chris Domingo, que es el Risk Control Director de Willis, Watson, y Chris nos va a hablar de las lecciones aprendidas de la fuente de seguros, que es una de las fuentes principales de pérdidas de seguridad de procesos materiales a la propiedad, digamos, y va a ser muy interesante. Adelante.
Okay, good afternoon, everyone. Sorry, Mike. I'll try that again. Good afternoon, everyone. It's a great pleasure to be here, and thank you very much to CCPS for inviting me here. And yes, I guess being the last presentation of the day and the conference is a great honor. And I know everyone had a good lunch, and I hope to keep you all awake. So we'll see how I do. Okay. Right, just a brief introduction on who I am. I'm a risk control director with Willis Towers Watson, based in London. For those of you who don't know what Willis Towers Watson do, they're a global insurance broker. So my current job, and it's been my job, I think this is the 9th year now of doing this, but basically I travel all over the world looking at insurance risks for oil and gas facilities. So that's upstream and downstream, onshore and offshore. It's drilling rigs, platforms, FPSOs, refineries, petrochemical plants, LNG plants, anything to do with oil and gas. So it's quite a great job, very interesting, very demanding, but also gives me a lot of insight into a lot of loss incidents and events that are happening around the globe. So, without any further ado, we'll start with the topic of today, which is catastrophic incidents, lessons learned. And there are many lessons to learn from catastrophic incidents, but I guess what I'll do first is just go through my presentation agenda. So, I'll talk about what is a catastrophic incident. And when I was putting this presentation together, although I know what a catastrophic incident is, and I know many of you know what should be there, it was interesting to see what the definitions were, which I'll show you in a minute. The next thing I'll talk about is lessons learned from historic catastrophic incidents. And there are many lessons to be learned there. And yeah, okay, I won't talk too much about that right now. All I'll say is these historic catastrophic incidents are ones that you will have all have heard of, and you know many of the lessons learned, but it's good to revisit these and then just see what's happening now. The next I'll talk about a catastrophic incident, which is a case study. Here I've tried to make it relevant to both upstream and downstream. Although it did occur in a downstream facility, it's definitely applicable upstream. Then I'll talk about loss incidents in the Latin American oil and gas industry in particular. After that, we'll talk about recent major loss incidents in the global oil and gas industry. And then we'll talk about the real lessons learned. So, what is a catastrophic incident? Well, I picked up 3 definitions. One is the Oxford English Dictionary definition, which says catastrophic incident is one that involves or causes sudden great damage or suffering. The Cambridge English Dictionary definition says a catastrophic incident is a sudden event that causes very great trouble or destruction. And the Collins English Dictionary definition says a catastrophic incident is something that involves or causes a sudden, terrible disaster. Really not good things. And I picked up the key words: sudden, great damage, great suffering, great trouble, great destruction, terrible disaster. Really, none of those things is what you want. Okay, let's look at some lessons learned from historic catastrophic incidents. And here I've picked one upstream and one downstream. The upstream one is one that everyone is fully aware of in this audience. So I won't spend too much time on this, but just to give you an incident summary and the actual lessons learned. So, Piper Alpha. Everyone's heard of it, right? Can I see a show of hands? Okay, great, perfect. Okay, this happened just over 30 years ago. They marked the 30th anniversary in the UK a couple of months ago, so I think it's quite pertinent to bring it up here. It happened on the 6th of July 1988. It's the worst UK oil and gas disaster that we've had. 167 people lost their lives in this fatality. Many more injured and traumatized. You know, the platform was engulfed in flames and fire and eventually collapsed into the North Sea, and the cost of the loss was £2 billion, equivalent to $5 billion US in today's money. So a great loss, you know, in terms of financial losses to the company as well as the property damage involved. It represented 10% of the UK's oil production at the time, and yeah, the fires were burning for 3 weeks after the initial explosions. So yes, a real catastrophe. So what lessons were learned from this incident? There are about 7 listed here. One is management of change, design issues. So the Piper Alpha platform was originally designed to export oil, but then retrofitted to export gas and condensate. And the original design case wasn't reviewed sufficiently to take into account the additional risks that gas and condensate would put on the platform. And even the position of the gas processing module, was not good at all. It was put under the control room. So when the first explosion happened, it rendered the control room useless. There was no communication available to the outside world, and the interconnecting platforms, which we'll talk about later on the list. The next thing was personnel safety over process safety. So here, the firewater pumps were put on in manual mode to prevent divers from getting injured. Now, the suction for these firewater pumps typically had a grill to prevent people being sucked in to the pump impellers. But a few years before the incident, a diver got injured, and rather than put in measures to prevent that from occurring, they said, well, we'll put all these pumps in manual instead, and then we won't have a problem. Well, guess what? When the incident occurred, the fire blocked off the access to the firewater pumps, and they were never used. Whether it would have made a difference to this catastrophe or not, no one knows. But on other platforms, what they did was put in communication in place, because really most divers wouldn't be in that vicinity of the firewater pumps, not normally. And even if they were, you could put impairment procedures in place, because it will only be for a short period of time, might be half an hour or an hour maximum. And you could have someone there in the firewater pump house on a radio, and then once that work is done, switch from manual to auto, and everything's fine. But sadly, that wasn't the case. And they had, the whole platform had a very extensive deluge system, water deluge system, but it was just never used. Okay, what other lessons learned? Permit to work and isolation for maintenance. So I know everyone knows about this because a lot of work has been done in the industry to improve permit to work as a result of this particular incident. But basically, a pump was restarted without any, without the maintenance being completed. And also, there were some issues with isolation, with a process safety valve not being in place. So there are a number of issues, but we won't go into too much detail because I don't want to bore everyone with that. Another thing was handover. So there was inadequate handover between crews, discipline, shifts. And I think, you know, well, we'll come to that, but it was an issue at the time, so things were not handed over properly, and yeah, we'll discuss later on whether that's still an issue today. Another thing was the interconnection. So no rig is an island. It was connected to a number of rigs. A lot of the interdependencies of Piper Alpha were not considered, and how they would respond in an emergency event, which is the next emergency response. It covers two things. One is the evacuation of people, but also what those other platforms needed to do in an emergency event, because the platforms, Clayton and Tartan, were still pumping oil when this event was going on, which led to a big pool fire and more explosions, and yeah, domino effect, and yeah, it was unrecoverable. And the last thing here is safety culture. So there was complacency. Yeah, everything's fine, no problem. Well, it's broke, don't worry about it, we'll move on. Only when the regulator comes and tells us we need to do something, then we'll do something. Otherwise, we'll do nothing. A lot of the issues with permit to work and shift handover, a lot of the failures of those things occurred in an event that happened just under a year before, where a rigger was killed. But none of the management did anything about that. And even today, in some of the presentations and discussions that you've had, you've seen that there's been some issues with safety leadership in facilities. So let's look at another historic catastrophic incident. This is a downstream one, which many of you will know, Phillips 66, Pasadena. And this was just under 29 years ago. So it happened on the 23rd of October in 1989. There were 23 people killed, with 100 to 300 people injured. So this occurred at the Phillips 66 Pasadena Chemicals Complex near Houston. And basically there was a leak of chemicals from the polyethylene plant, and this led to a vapor cloud that ignited and led to a massive vapor cloud explosion, and the total loss for this incident was $2 billion. The work on the polyethylene reactors started the day before. We'll go on to some lessons learned, but yes, the vapor cloud ignited within 2 minutes. So there wasn't much of a response time once the hydrocarbons were released. And a number of lessons learned. Some are quite similar. So maintenance procedures, isolation, they're using single isolation, recommissioning of instrument air, training and competence, because they they were meant to disconnect the air, but even when they attached it, the valve worked the wrong way, so they wired it up wrong. Many issues. maintenance and supervision, permit to work systems were not used. So the working hazardous areas with no permit to work, leak and gas detection, no. They had a lot of inventories of hydrocarbon in that facility, but no gas detection. No gas detection on the control rooms where it was positioned, and also it was positioned very close to process plant, so a lot of issues there. Active, passive fire protection, issues with fire water pumps again. So you can see that there's some recurring themes. They were quite unfortunate. They had electric fire water pumps and diesel fire water pumps. The fire burnt the cables, the power cables for the electric fire water pumps, but they had 3 diesel pumps as backup. But unfortunately for them, one was out of service and the other one ran out of fuel. So, yeah, and to be honest, we see this a lot from those that carry out insurance risk surveys. You know, sometimes you wonder why we say, okay, your diesel day tank for your fire water pumps, you know, the standard says you need to have them at least 2/3 full. You know, they should be sized for, 24 hours. And at least if they're 2/3 full, at least they'll run for, more than 12 hours. So that should help you out. But if they're empty, then it's pointless. Another thing was warning signs, human factors. Their audible alarm systems were not heard in many areas of the plant. So this is, some basic stuff. I mean, if you're going to have any alarm system, everyone needs to be able to hear it. And if they can't, then there's a major problem. And then emergency response again, site emergency plans, drills, things like that weren't done on Piper Alpha, weren't done here, and you can see the result. Okay, so these are quite historic, 29, 30 years ago. Let's see a catastrophic incident and a case study. Some of you may be aware of this, but maybe not all of you. Okay, let's see if there's anything different. Right, the outline of this incident. This happened in the year 2000 in the Middle East. It was a loss of primary containment, originated from a third-party transfer line running through the refinery. So it was a Middle Eastern refinery. The line was a 10-inch carbon steel above-ground pipeline carrying unstabilized condensate at atmospheric or ambient temperature and 40 bar. So reasonable pressure, you could say maybe high pressure. And then there was 50 minutes from initial discovery to the full line rupture. And the line rupture was due to a closure of a downstream valve and auto refrigeration. The released material formed a vapor cloud with delayed ignition, and this resulted in a catastrophic vapor cloud explosion event and fires following. Okay, got some photos to show you. Yeah, not pretty. Okay, some more photos. That's the firefighting effort after the explosions have taken place. So you could see a lot of firefighters there involved in trying to put out those fires. Some more photos. Control building destroyed. So remember in the Phillips 66 Pasadena incident, we talked about plant layout. There were some issues with the control building there. Similar issue here. Some more damage to process units. Yeah, just showing the extent of the damage, and yeah, not good. Okay. Consequences of the loss. Right. So this happened in 2000. There were 6 fatalities and about 50 people injured. There was a total economic loss to 5 refinery process units within a 100-meter radius of the blast, and there were another 3 process units that were also extensively damaged or severely damaged. The property damage caused by this event was $375 million, but the business interruption for this refinery was $1.5 million a day. Unfortunately, this particular facility bought insurance, but property damage only, not business interruption. So the overall loss was about $2 billion to them, but only $375 million was covered by insurance. The refinery took 3 years to start up again after this loss. And I highlight the 50 minutes they had to do something before they had the release and the delayed vapor cloud explosion. Right, causation. There was severe internal pitting corrosion on a section of the pipeline at the 6 o'clock position. There was degradation mechanisms due to water dropout, chlorides and hydrogen sulfide in the lines. Some external corrosion was also noted. It's due to the nature of the environment, moisture, wind, blown environment, saline, sandy environment. The 2 modes of corrosion acted together in the area of the pipeline support. A key thing here, the pipeline had been pressure derated some years earlier following internal inspection, which was intelligent pigging, by the third-party owner who discovered the pitting corrosion from that inspection technique. But what was done about it? There was corrosion in the line. They said, okay, we'll lower the pressure. That's it. Nothing more. And did they tell the refinery owner about that? Well, we'll see. Next, inspection results not communicated between the different ownership parties. So the refinery owner didn't know that there was a third-party pipeline suffering corrosion going through his facility or her facility. So that's the failed condensate pipeline, the north and south ends. Not a big line, but catastrophic result. So what are the lessons learned from this particular event? There's some mechanical integrity learnings, inspection program for off-site piping, typically neglected in facilities like refineries, petrochemical complexes. They always think about the process units and not so much the off-site piping, especially when it's not owned by them. So risk-based written schemes of examination, check for corrosion at pipeline supports. So basically the corrosion happened where the pipeline was being supported. That's what the 6 o'clock position means, if people don't realize that. And then communication between the inspection parties and audit of the third-party inspection activity. But there's some other learnings. Management of change. The pipeline had been pressure derated some years earlier. Where was the management of change there? Was it done? No. Operating procedures, training, competence, management and supervision. They had 15 minutes to respond to this. The operators would have seen that the pressure was increasing in the line because there was a downstream valve closed. Did nothing. Why? Leak gas detection, positioning of detectors. There were no detectors in that area. They had some time before that vapor cloud ignited, but they didn't detect it. Active fire protection in that area, non-existent. Emergency response, no emergency response plan for off-site or for the off-site area. Some reoccurring lessons here. Contributory courses, identification of off-site pipelines, so labeling of pipe work, isolation of off-site piping, so remote actuation or accessible manual. Definitely remote isolation is much better. You could do it from the control room, and it's much faster. And identification of isolation points, and the most important of these is the communication between the ownership parties. So if you have any pipelines going through any of your facilities that you don't own, please be aware of the inspection activities that go on with that pipeline. Ask to see the inspection results. And if there's a problem, take it up with that third party. And if you're not happy with the inspection results you see, tell them they can't run that line or lines. Okay. Now, we've seen some lessons learned. So I think, have we learned anything so far? Maybe. Now, we're going to look at loss incidents in the Latin American oil and gas industry in particular. When I was looking at this data, I had no idea what the results would show me. So I didn't know what to expect. I just had an open mind. I looked at this data last week, and I think Kristen mentioned about data mining and number crunching. Yeah, it's a bit painful, but the results are worth it, as we'll see now. So, total losses over the last 30 years for the Latin American oil and gas industry. Now, what I've done here, let's see if that works. Oh, sorry. How do I get back? Yeah, I try to use the pointer. Okay, that's fine. Sorry, I tried to use the laser pointer, but it didn't work. So that's my bad. Okay, right. Yes. Okay. So just to clarify, the Piper Alpha disaster was in Europe, in the UK. So this is just pointing out when it happened, but the losses are nothing associated with that. This is not like the European oil and gas industry losses. And the same for Phillips 66, Pasadena. It's nothing, it's just stating when it happened, but the information here, the loss information here is, nothing to do with North America. So this is just Latin America, oil and gas industry, upstream and downstream. 30 years worth of data. Right, so looking at this graph, you can see that, okay, there were a few peaks in odd years. Okay, something happened in 2001. There was a bit of a step change, but in general, the losses were not huge. But look at the last 8 years, 2010 to 2017. A big step change in the total losses. I found that very surprising. That's not what I was expecting to see when I looked at this data. So something is going wrong somewhere. Are we really learning from catastrophic incidents that have happened and are continuing to happen? Is this a problem with Latin America, or is it a global problem? Okay, let's see if we can answer some of these questions. But also, this is total loss information, right? The highest one, sort of Let's see if that's working. Yeah, around the $2 billion dollar amount. And I'll just explain a little bit about the figures. Willis Towers Watson, being an insurance broker, we have a lot of access to incidents in the insurance industry and a lot of data. Now, most of this data is property damage data because not many companies buy business interruption, especially in Latin America. There are a few, but not that many. So this total loss number is property damage plus business interruption, and for offshore assets like drilling rigs, it also includes operator extra expense, and that really is control of well. So most of this data is property damage. So actually, the actual total loss number is actually higher, if that makes sense. Now, looking at this, you think, okay, what's happening with the number of loss incidents? Has that changed also? Let's see. Right, so this is the area of Piper Alpha and Phillips 66 Pasadena. On average, 10 losses a year. But see where we are now, last 8 years, you're around 40 losses a year. So that's also gone up, and you can see there's been a step change, significant step change. So, what's going on? Okay, let's see whether it's a Latin American problem or a global problem. Let's look at some recent global oil and gas industry losses. Now, this data is split into upstream and downstream. So we'll just look at the different geographical regions of the world. Okay, we'll start with Australia. And just to explain this data, this is upstream losses greater than 100 million from 2015 to 2017. So, for example, when we look at Australasia, they had no losses greater than 100 million over that period. Doesn't mean that they didn't have any losses, but there were no losses above 100 million. That's the same for Asia and Europe in upstream. But looking at North America, there were a total of 3 upstream losses, which totaled about $1 billion. In South America, we had 7 upstream losses that totaled $1.9 billion. And I guess the winner, or not, depends on how you look at it, the Middle East and Africa, there were a total of 5 upstream losses greater than 100 million, with a total of 2.6 billion. Right. Let's look at downstream. Very different. And you can see who the winner is here. Europe. Oh, where I'm based. Yes, not good. Okay. Australasia is the same, so no major losses above 100 million. But that's understandable because compared to the other regions of the world, they have a lot less oil and gas facilities. The next is Asia with 2 downstream losses greater than 100 million, so 0.2 billion. And then South America, a bit better in terms of the numbers of downstream losses. So there was only 1 downstream loss during that period, and that was $500 million. Middle East and Africa, there were 3, and it's 1.2 billion. One thing to say, though, is in reality, the Middle Eastern one is actually higher, will actually be the highest. There's an ongoing loss at the moment, I won't name that, but by the time you include the business interruption with that loss, that number will be the winner. Okay, North America, the total of 10 downstream losses, with a total of 2.6 billion. And then Europe, the winner at the moment, but that will change. 9 downstream losses, 3 billion. So, is this a global problem or Latin American problem? What do you think? Okay, great. So, it's a global problem. We're all not doing things right. So, let's go to the real lessons learned. So first, I'll just show some headlines for the Latin American oil and gas industry. Key trends. Loss incidents. You had 741 loss incidents, some catastrophic, over the last 30 years. The total losses were $11.3 billion over the last 30 years. Upward trends. Number of incidents, 299 in the last 8 years. Total losses, 7.6 billion in the last 8 years. So almost 50% of your losses have come in the last 8 years, and about 70% of the total loss number in the last 8 years. So yeah, the trends, the recent trends are not good. And we're seeing that this is a global problem. Downward trends. Oil and gas facilities are getting older, so therefore more loss incidents are imminent. My thoughts, there are many recurring lessons learned from loss incidents. And in terms of major loss incidents in Latin America, oil and gas industry, there have been 8 major loss incidents in recent years. So, what have we really learned? There are many lessons learned from catastrophic incidents, but are we really learning our lessons? That's a question as well as an exclamation mark. I don't believe we are, because it's the same recurring themes. So, similar lessons learned from catastrophic loss incidents seem to be reoccurring. Management of change, permit to work, isolation practices, leak and gas detection, mechanical integrity, etc. And we've seen in some of the discussions today some recent examples of issues with permit to work, with isolation, with design. So these keep reoccurring. Now, some of the ways forward to deal with these things. One is sharing of high potential incidents, so we call them hypo incidents, between Latin American oil and gas companies, is one of the ways in which we can tackle these worrying trends, increasing number of loss incidents and increasing total losses. So I'm just going to go back to this. The number for Europe, upstream losses, especially offshore, upstream. No major loss events greater than 100 million. Why? That number didn't surprise me, because based on the insurance surveys I've carried out in Europe, especially offshore, they have a very good network of sharing high potential incidents. So all the operators, they have an organization. If there's a high potential incident in one organization, it's spread within that organization and with all the other operators. It's great. I won't tell you what particular country does that, but it's in Europe. Okay. Another thing, another key thing, is that oil and gas facilities in Latin America need to be renewed. Most are over 20 to 30 years old. Now, when designs of these facilities are done, they're typically 20-year design life, 25 years, 30 years. But a lot of these facilities are much older than that, and yet they continue to be used. Where's the management of change there? Where is the risk assessment done to say, right, you can continue using those facilities? Is there any interrogation of the original design? Are you far away from that? Has there been any redesign done? You know, what analysis has been done? Do you just say, right, this is end of life, we scrap that and we start again? But if we do nothing, then other losses, major losses, catastrophic losses are imminent. Thank you for your time and attention.
Question, the first.
I get the first. One question. We're not learning from the incidents. I think everybody in here agrees with that. Why?
Wow. The answer to that is, I don't know really, but what I would say is, based on my work in the insurance industry and many discussions with clients and their personnel in process safety and maintenance and inspection, how do I put it? There's some good actors, but there are many bad actors. Some are due to really not wanting to, or not having an open mind. So some are cultural. Oh, we've always done things this way for the last 30 years. Who are you to tell me I need to improve this, that, and the other? So those are some of the issues. Others are due to lack of investment. There are also others due to lack of competency, which was also mentioned. But there are also a number of good actors, as I said, that are actually working to improve things. So revamping of units, building new facilities. So some are actually taking a more proactive approach, but it's not enough. We need more oil and gas companies to actually take the lead and do these things. Okay, I know.
Hi Chris, how are you?
Yeah, very good.
Okay. Thank you for the statistics and the trends, which is actually what I would expect in our job. During our surveys to different countries in the world, and we usually issue recommendations.
Yes.
Right? Those make to fill the gaps and make improvements. What is the trend over the last 10 years of rejected recommendations or outstanding recommendations that stays there for years? 10 years, 15 years, that could have been implemented in 3 different turnarounds time.
Yeah,
I have the same.
Yeah.
issue.
No, that's a very, very good question. So what Fabio has just mentioned is that when we carry out these insurance surveys, we call them risk engineering surveys, we tend to give risk improvement recommendations at the end of those surveys. I think over the years I've given many. Depends on the clients. So we have some really good actors that take these insurance risk recommendations very seriously, and they cover a lot of those issues with lessons learned that we've seen: management of change, permit to work, active fire protection, supervision, training, procedures. And a number of those very good clients try and implement those. Typically, insurance surveys on a 3-year cycle for most facilities. So usually, the good actors, within a year or 2, they've actually done those recommendations. So they're pretty quick. And when it comes to investments, okay, we need more remote isolation to isolate our hydrocarbon inventories, for example, or more passive fire protection, or more active fire protection, or additional fire water pumps and stuff. You know, they invest the money, they invest millions of dollars to actually improve, to prevent these incidents. But there are others, the real bad actors, that don't do this. And I've seen both. So just to highlight or answer your question, There was a facility, I won't name the company, visited them, gave them a risk improvement recommendation on mechanical integrity. That was in September of a particular year, but I won't mention it. Okay, I can mention the year, but it was September of 2011, and by December, Christmas time, they had a major loss, $100 million loss, as a result of not dealing with the mechanical integrity issues that they had on that facility. And it was a 5-year-old facility. Yes. So I hope that kind of answers the question.
Gustavo Correa, IPF. Thank you, Chris. Excellent presentation. And during your presentation, you show us some example who causes catastrophic events. But according to Willis Towers Watson or your personal experience, which are the top 1 or top 3 root causes who cause catastrophic events?
Okay. For me, based on my experience, I guess number 1 would be management of change, because that actually deals with a lot of issues. It covers process hazard analysis, it covers process design, it covers a lot of aspects, but a lot of people don't take that seriously. It also covers the management of organizational change. So if you're saying, right, we're going to get rid of half our operators because we want to save money, well, have you assessed the risks of that? Or we're going to get rid of loads of engineers or whatever. Have you assessed those risks? So for me, that's number 1. Number 2 would be mechanical integrity, because as I said, a lot of these assets, a lot of these oil and gas facilities are old. So there are a lot of maintenance and inspection issues. And number 3 would be safe work practices, because we seem to have a lot of issues with work permits, with isolation procedures, with having critical emergency operating procedures. So what do the operators do when there's a power cut? What do they do if they lose instrument air on the plant? What do they do in abnormal situations? And I think during the competency discussion, it was said that in terms of training, I think it was Chris Hawkes that mentioned that in terms of training, in emergency we're good at training people in normal situations, but in emergency situations, we're not really good at doing that. And I've experienced firsthand when I used to work in industry and operations where we're in an emergency event, there's a big red button, emergency shutdown. We had a serious event. All the operator had to do is right in front of him, just press the button. He was there transfixed. Didn't know what to do. I had to press it for him. So, yeah, I believe those are the 3 main things. Does that kind of... Okay. Any further questions?
Thank you for this wonderful presentation. My name is Santiago Cepeda. I'm working for Chevron. What about the lack of communication derivative because the legal aspects? Is something that we need to learn fast because we have some constraints of the lawyers?
Not necessarily. So for example, the catastrophic incident case study that I shared with you, that's one of our clients, but you don't know who that is. Because you can sanitize the data, you can sanitize the information. The aim is to share. We need to share all our knowledge on these incidents so people are aware of these things, look for these things, and help prevent those things in their facilities. And all of you need to share with one another, because your solution is with someone else, likely, and their solution is with you.
Thank you.
No worries. Okay.
Okay, thank you.
Thank you.